It is a Tuesday morning in New York. You buy a coffee and some groceries, sliding your card into the terminal. The payment goes through in a fraction of a second. 10 minutes later, that exact same card number is used to buy a $2,000 laptop at an electronics store in Paris. To understand how the bank processes this anomaly, we have to look at the system catching these swipes, an online transaction processing database, or OLTP. Its entire job is to record incoming data as fast as humanly possible, without pausing to ask questions. Look at this diagram showing our processing node. If this live database stopped to scan your 5-year purchase history to verify that Paris transaction, it would drag a massive monolithic block of historical data into the pipeline. The entire global payment network would freeze. Banks are forced into a difficult compromise. To maintain lightning-fast daily operations, they have to physically separate those rapid-fire checkouts from the heavy, long-term historical analysis needed to actually spot theft. The solution starts after hours. Every night, an extraction pipeline pulls millions of raw transaction records out of those live checkout databases. These records are permanently deposited into a data warehouse. This centralized repository is optimized for reading massive historical archives without slowing down active networks. Inside the warehouse, data uses a star schema. A central fact block holding quantifiable metrics is surrounded radially by dimension blocks containing context. The database sweeps this structure, pulling numbers into the center to calculate spending history almost instantly. This warehouse gives the banking network a perfect, highly accessible memory. Analysts query millions of past transactions without risking a bottleneck in the live checkout systems. But having a perfect memory creates a new problem of scale. Human analysts cannot manually search through billions of warehoused rows to flag individual fraudulent patterns. They rely on an automated framework called Knowledge Discovery in Databases, or KKD. This multi-stage engineering process extracts hidden insights and actionable rules from raw warehouse data. During the central mining phase of KKD, the system rapidly feeds your entire history of past transactions into highly advanced predictive classification algorithms. These algorithms evaluate millions of data points to categorize your behaviors automatically. This scatterplot chart illustrates how the algorithm builds a mathematical baseline of your specific behavior, grouping hundreds of normal transactions into a dense, predictable cluster. When a radically different purchase occurs, with unusual locations or amounts, it plots as a glowing red outlier, far outside your normal pattern. Through data mining, the bank transforms static logs into an intelligent, individualized baseline of your behavior, ready to be deployed as an autonomous defensive shield. Let's bring this back to that electronics store in Paris. Right at the millisecond the $2,000 fraudulent charge hits the live banking network. At the moment of the swipe, the network relies on an active database. Traditional databases are passive. They only act when explicitly commanded by an outside application. An active database monitors its own internal state and triggers operations autonomously. This flowchart maps out how the active database achieves this automation, using an event-condition-action architecture. It starts with the event phase. The database receives the packet from the Paris swipe, initiates an automatic internal check, and pushes the data forward into a branching decision gate. This is the condition phase. The database instantly compares the incoming swipe data against the personalized KDD behavioral baseline we built earlier. Since the location and amount deviate so wildly from your normal cluster, the condition flags a massive anomaly and routes the packet down a rejection pathway. Finally, it hits the action phase. Because the anomaly condition was met, the database fires an internal stored procedure to autonomously decline the card and lock the account, all running directly on the database server. Integrating historical warehousing, predictive mining, and active architecture turns the modern database into a real-time autonomous defense system.